Welcome to today's video. Today we're going to be expressing square roots of whole numbers in simplest form and show that mastery by scoring at least a 70% on the exit ticket. Hopefully you have a note sheet in front of you. If you don't, take out a blank sheet of paper and we'll get you a fresh one tomorrow. Now, I know some of you are probably saying, why am I in algebra and working on square roots? I know square roots. Yes, you do. You know square roots of perfect squares. However, we're going to be focusing on non-perfect squares. And yes, we can just type them right in a calculator and get a decimal out. But in algebra, we don't like decimals. We don't want decimals. We want our answers in radical form with the square root just simplified. So we have to learn square roots. Now, for our steps, the first step is to create a factor tree for the number underneath the radical symbol. In this case, our radical symbol is the square root sign. And for those of you who don't remember a factor tree, it's all the prime numbers that multiply to get the original number. Step 2, we're going to cross out all the non-prime numbers. So any number that we could keep breaking down, we're going to cross it out. Then we're going to circle all the pairs. Now this is important. When we do square roots, it is anything that you have a set of 2 of. Square root, if you think of square, if I say to square a number, you multiply that number by itself. So you're doing it x squared to the second power. So we need sets of 2. Then all the numbers that we did not circle are going to stay inside the radical symbol, and everything that we circled is going outside. If there's multiple, we're going to multiply. Now, we're going to go through some examples together. If we look at the square root of 81, step 1, I need to create a factor tree. So if I take 81, well, I know that 9 times 9 gives me 81. Those are not prime numbers, so I'm going to keep going. 9 is 3 and 3, and that 9 is also 3 and 3. So now I have all prime numbers at the bottom of my tree. So now I'm going to cross out all numbers that are not prime. Well, 9 we simplified, and that 9 we simplified. And I'm going to circle pairs. Again, pairs is 2, so I have a pair of 3s here and a pair of 3s there. Now, all numbers not circled go inside, and all numbers circled go outside. In this case, I don't have anything not circled, so I don't need anything underneath the radical symbol. And I have two sets of pairs circled, so I'm going to multiply them. In this case, 3 times 3 is 9, and that's your final answer. And yes, I know it's basic. I know you know the square root of 81. But we wanted to start with an example you know to prove that this is going to work, even for those perfect squares if you forget them. If we look at example 2, we have the square root of 192 in simplest form. So I'm going to start with my number, 192, and I need to create a factor tree. So I need to get it down to all prime numbers. Well, it's even, so I'm going to do 2 and 96. That's also even, so 2 and 48. 24 and 2, I'm going to run. I'm going to do 12 and 2. 12 goes to 4 and 3, and 4 goes to 2 and 2. Now, from here, we want to cross out all those non-prime numbers. So anything that does not have stems coming off of it. 96, 48, 24, 12, and 4. All my other numbers do not have stems coming off of it, so they are prime. Now we need to circle pairs. Well, if I look, I have a pair of 2s at the bottom. I have a pair of 2s right here, and I have a pair of 2s right here. That 3 doesn't have a pair, so we're just not going to circle it. So now, again, we want the circle on the outside and the non-circled on the inside. So on the outside, I have 2 times 2 times 2, because I have 3 different pairs of 2, and my non-circled number is 3. Well, 2 times 2 is 4, times 2 is 8, so we get 8 times the square root of 3. That is in simplest form. Because we cannot break down the number underneath the radical symbol any farther, it's in simplest form. If we look at the third one, what is the value of negative 3 times the square root of 40 in simplest form? Now, this one's important because if we look at step 1, it says create a factor tree for the number under the radical symbol. Negative 3 is not under the symbol, so we're not even going to focus on negative 3 to start. We're just going to start with the number 40. I'm going to break it down. Well, I know it can be 2 and 20. 20 can break to 5 and 4 can break to 2 and 2. Now that I have my tree, I'm going to cross out all the non-prime numbers, so anything that has a stem coming off of it. And then I'm going to circle my pairs. Well, I have a pair of 2s here. I don't have a pair for that 2, and I don't have a pair for that 5. So now if I put the circled on the outside and what we didn't circle on the inside, I only have one pair of 2s on the outside. On the inside, I have, however, a 5 and a 2. So we're going to multiply it. So from here, it looks like our answer should be 2 times the square root of 10. However, we do have to remember back in the beginning of the problem, we didn't worry about that -3. Well, that needs to be part of our answer. We can't just disregard it. Since it's already outside, we're going to do exactly what we would do as if it was another pair, and we're going to multiply it. So -2, or -3 times 2 gives me -6, and the square root of 10 stays the same. So that's my final answer, -6 times the square root of 10. That is in simplest form. But again, we only want to do it for numbers underneath the radical symbol. So that -3, we don't have to try and simplify that down. We only look at the 40 to start, and then we multiply our answer times -3. The last one, is 4 times the square root of 119 in simplest form? So this is a yes or no question, but you need to be able to back your answer up. I don't want you guessing yes or no because it seems like a good answer. You can do this and you can prove it. It doesn't take a lot. We're going to go through the same steps. So number 1, create a factor tree for the number underneath the radical symbol. Well, 4 is not underneath the radical symbol, so I'm going to 119. If you try and find a number that divides into 119, you do get 7. And you get 17. Both 7 and 17 can't be broken down, so we're done. So now we're going to cross out all numbers that are not prime. Well, there were no prime numbers. We can't circle any pairs because none of the numbers are the same. Because we cannot circle any pairs, that tells me 119 is already in simplest form. So is this answer in simplest form? Yes. Because 119 cannot be broken down. Now, one note you might want to make yourself, because some of you might have looked at this and said, oh no, it's not. I know 4 is a perfect square. 4 does not matter because it's outside that radical symbol. It does not matter because it's outside the radical symbol. So any number that's out in front, if it's asking if it's in simplest form, we're just going to disregard that. We're only focusing on the number underneath the radical symbol, just like if it asked you to simplify it, you only focus on the number underneath the radical to begin the simplification. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.